students. I hope that all of you are doing absolutely fine and amazing, and all of you are staying very healthy, hydrated, and happy in this lockdown period. So, guys, today we will be beginning with a new chapter, that is Matter Around Us Pure of Class 9 Chemistry. And today we will be finishing up with this chapter in one shot. So in this session, all your doubts are going to be clarified, and as you know, only this chapter is there in your term 1 exam of your school of class 9th. Okay, in which only MCQs are going to be asked. So we will be focusing on the concepts in depth, total depth understanding plus important questions that you will be getting. Okay, everyone. So what are we exactly going to do in today's session? Is Matter Around Us Pure in one shot to score 100% in term 1 exams. So by the name of the chapter only, we are able to understand that this is posing a question to us, that is matter around us pure? Do you think matter around us is pure? Before moving further with this chapter, you should be clear with this term matter, that what is exactly this term. So what do you think matter is? Okay, so finally we're getting started with this chapter, which is actually a question to us that we have to understand, and we have to develop the understanding for it. Okay, now these are the things, these are your general stationeries that you use, your pens, your pencils, your scissors, your notebooks, your paper clips, your sharpeners, erasers, highlighters. But what is common in them? Now don't say all are non-living things, please. Give me a valid reason. What do you think? What are you able to find common in all these things? The thing is that all of them are composed of matter. All of them are matter. Okay. Now in chapter 1, I wanted to complete it, but actually it has got deleted. So please remember, you don't have to study it. But still, matter's definition is important. What is matter? Matter is nothing but anything which occupies space and has mass. So anything which is present in our surrounding, which occupies some space and has some mass in it, that is matter. I gave the example of, I guess, a pencil box in that. Let's say if I have a diary. Wait a second. Yeah. So this is my diary. So it is occupying some space and it has some mass. So I can say that my diary is matter. So everything present around you, that is nothing but matter. Easy. Then you would ask, is air a matter? Do you think? Let me know in the comment section. Okay. But I will tell you that yes, air is also a matter. It is a gas. Alright, wait a second. Okay, so air is a gas. Okay. Moving on to the classification of matter. So matter can be classified into two groups. First group, pure substances. The second group, mixtures. So you have two kind of classifications. One is your pure substances, one is your mixtures, and we will be understanding what are both of them in detail in today's session. So stay till the end, everyone who's watching it. And the separation techniques which are used for separating them. Now first, let's try to understand about the pure substances. What are they? See, in your general life, what would you think? What are pure substances? Okay. Yeah, see, if I talk about myself, I think that if a substance is pure, in the general opinion, if there is no adulteration in it. Suppose if you have a milkman, if the milkman comes to your house to give you the milk, then what would you expect? Is the milk pure according to you? You would say that the milkman shouldn't add much of water, he shouldn't add oil in that, and it should be unadulterated. Adulterated means when we add something which is like a chemical kind of a thing, which we call मिलावट in Hindi, कि मिलावट कर रहा है दूध वाला, right? So that shouldn't happen. Okay, that's why milk is pure. But actually, if I talk about chemistry, then in chemistry, pure substances mean the substances which are made up of only one type of constituent particles. Okay, so here I am talking about the particles. That particles should only be of one type. There shouldn't be many kind of particles. And also pure substances cannot be separated by physical methods. Okay, because there is only one type of particle, so you cannot separate the particles out. Okay, like for example, I have water, H2. I have my H2. H2 is made up of very small particles, and all are the same particles. So I can say that water is pure. Yes or no? Water is definitely pure. Now moving on to mixtures. Now mixtures is like the opposite of pure substances. If in pure it is made up of only one type of particles, in mixtures it must be made up of different particles. It is made up of different constituent particles in uneven ratio, like different ratios, like whatever the particles are there, they are in different ratios. Now these can be separated by physical methods like heating using filter papers. As it is having more than one particle, the particles can be separated out. Okay, now what are the types of mixtures that we are having? Like I said, milk, sugar solution, salt solution, oil, pizza, all of them are mixtures because they are made up of more than one type of particle. Like milk has a lot of impurities, okay, and other things are also there. I hope that is clear. Now before moving on to pure substances, just give me a second. Yeah, now pure substances can be further classified into elements and compounds. अब elements क्या होता है, compounds क्या होता है, ये समझना बहुत important है for now. First of all, let's talk about elements. So elements are the purest form of matter, which is made up of only one type of constituent particles. Okay, I'm repeating, element, any kind of element that you see, that is you can say the purest form of matter. Nothing can be purer than that, like at the bottommost level, right? One type of constituent particles like oxygen, O2, you can say iron, gold, carbon, helium. So they all are made up of one type of particles like oxygen atoms, iron atoms, okay, gold atoms, carbon atoms, and helium atoms. So here you're able to see the gold and this, okay, iron. Clear everyone? So this is about elements. Now, based on chemical properties, elements have been divided into three parts. So based on their different chemical properties, how do they react, how do they behave in the environment, based on that we have three. What are they? Metals, non-metals, and metalloids. We have three groups that we will be discussing about. Let's discuss each one of them. Now first, let's talk about metals. Now what are the properties of metals? That metals are ductile. What do we mean by ductile? That they can be drawn into wires. Okay, then what is malleable? How are metals malleable? Because they can be beaten into thin sheets. Generally children get confused between ductile and malleable. Ductile means when they are able to drawn into wires. Let's take an example of copper. Copper can be drawn into copper wire, very thin wire. Okay, so that means copper is a ductile substance. Malleable means beaten into thin sheets. Like we talk about gold. Gold can be beaten into very thin foils, like even the you can say one cell thick kind of a thing. One cell thin, I mean. Okay. Now metals are good conductors of heat and electricity. Okay, they conduct electricity. They allow heat and electricity to pass through them. आया समझ में? Lustrous. Lustrous का मतलब होता है that they shine. They have a shiny appearance. अगर आप metal को देखोगे, then you will be able to see that they shine a lot. Metals shine करते हैं. And sonorous. Sonorous means ringing sound. Let's say आप कोई भी metal को ऐसे या तो टेबल पर बजाओगे या कुछ करोगे, then you will be getting a sound. Metals are sonorous. Non-metals are just the opposite of them. They have a variety of colors. Then they are, let me change the pen. They are poor conductors of heat and electricity. They do not allow heat and electricity to pass through them. They are non-lustrous. They do not shine. Non-ductile. They cannot be drawn into wires, and non-malleable. You cannot beat them into thin sheets. Okay, so you can learn by like rainbow kind of a thing. They are somewhat like rainbow. Okay. Now metalloids. Now metalloids are a kind of exception, you can say, or they are again, they are beach ka kind of a thing, because they are the elements which are having properties of both metals and non-metals, that are intermediate between those of metals and non-metals. Like both of the properties they are having. For example, we have silicon, arsenic, germanium. So these are the metalloids that you are having. Metals, iron, silver, gold, right? Magnesium. Non-metals, you can say oxygen, carbon, chlorine. And one more thing I wanted to tell, that generally metals are solid, okay, and non-metals are liquid and gaseous. In class 10th you will be reading about liquids or gases. Generally, not all exceptions we will be doing in class 10th. Okay. Now moving on to compounds. What are compounds? Compounds are also one of the purest form of matter, but just the difference between elements and compounds is that compounds are made up of, they are constituted by two or more different atoms combined together in a definite ratio. Although they are composed of two or more different atoms, but they are combined in definite ratio, that's why they are pure. Let's say sodium fluoride. What is sodium fluoride? Your NaCl. Water, H2O. Calcium oxide, CaO. In chapter 3, I will teach you how did I get to know these formulae. Okay, so they are made up of more than one substance. Okay, more than one pure form of matter. That's why they are, you can say, compounds. Like in English, you read compound sentences made up of two simple sentences. Same here, element is simple, compound is little bit complicated. Sodium chloride is your salt, okay? Do not get confused, those of you who don't know. It is the common salt, जो नमक आप खाते हो. Clear? Moving on, let's have an important note with us. The constituent particles of a compound cannot be obtained by physical methods, but the chemical methods can decompose a compound into its constituent units. In class 10, you will be studying more about it. For now, just understand that the constituent particles, the particles of compound cannot be obtained by physical methods. By heating, cooling, or any physical method, you cannot obtain the particles. They can only be done through chemical methods, generally when we have the different reaction. जब react करोगे तभी वो break हो सकते हैं, otherwise वो नहीं हो सकते. Please याद रखना, right? Okay, so properties of compounds are these, like for example, hydrogen atom, I have chlorine atom, carbon atom, oxygen atom. So they all are composed of one or the other atom, like hydrogen combined to form this H2 molecule, Cl. We will be studying covalent bonding in class 10. अभी के लिए छोड़ दो CH4 and O2. अभी के लिए just leave it. It's not that important. But remember this thing, that your elements react to form compounds. Two or more elements react to form compounds. Clear? And the new substance formed has totally different properties. What happens, the new substance that has been formed after the reaction of elements, that substance has totally different properties from the previous one. Let's say I have one
So let's
good example.
understand it with the help of an example. So suppose we have hydrogen and oxygen. So hydrogen and oxygen are going to react to give you H2O, right? Which is nothing but your water. You can balance it in this manner like I am balancing, but it's not very important. That you'll learn in grade 10, right? So for now, just understand this much, that hydrogen oxygen gases give us water plus energy, and the energy is in the form of heat, okay, which is released. So what we are able to understand from here, that two gases are giving me a liquid, right? So from gas I'm getting a liquid, which is a very new thing, right? Water is a product that is formed over here, which is a new product, and it has totally different properties from hydrogen and oxygen gases. Is that clear?
Now the constituents can be separated by chemical or electrochemical methods only, either by chemical or electrochemical methods, that is by your electricity. Okay, now
Okay, now let's talk about the mixtures. Mixtures can be homogeneous or heterogeneous. So there are two types of mixtures with us. Okay, so we have discussed about the pure substances till now. Now let's talk about the mixtures. Okay, so first, homogeneous mixtures. Homo means same, right? Homo means same. Genus means phase. So homogeneous meaning same phase. Hetero means different, and genus means phase, so different phase. Okay,
now the
everyone.
homogeneous mixtures mean that the components are uniformly distributed all over the mixture. So the different components of the mixture which um, constitute the mixture are uniformly distributed, like they are distributed in an equal ratio, phased ratio, and it is not easy to differentiate the component particles of the mixture. It is very difficult to differentiate or separate them. Okay, now for example, let's take the example of sugar solution, salt solution, brass is an alloy. Okay, it's just given in your NCERT, you can just read it. Okay, now before talking about alloys, I would like to tell you, like sugar solution, you take, when you dissolve sugar in water, then what happens? Can you separate the particles? It's very difficult, not very easy. because now this particles of sugar have been embedded into the particles of water, or I would use the term solvent. Okay, so this is about homogeneous mixture which are having the same phase, which are distributed uniformly. Clear? Now heterogeneous mixtures. What are heterogeneous mixtures? Just the opposite. In mixtures in which the components are not uniformly distributed all over the mixture and can be seen through a microscope. So the components can be seen through a microscope. They are not uniformly distributed. For example, sand and water. If you put sand and water, you will be able to see milk. In milk, although you cannot see because it is a colloid, we will be talking about it. Okay, and blood. Blood and milk are colloids. We will be talking. Don't worry. Sand and water, milk, blood. You can see the particles. Okay. Chalo. Now moving on to the homogeneous mixtures, they are having two parts. First is the true solution and the second one is alloy. So what is a true solution? True solution is your normal solution. Okay, a solution that is just, they have given the name as true solution. So true solution is a homogeneous mixture of two or more substances in which substance dissolved in solute. Wait a second. Yeah. So the solute, that is your solid substance, is dissolved, not solid I would say, in which is dissolved in it in the solvent, which dissolves the solute. Okay, so it's the normal, I can say the yeah. So this is the normal solution that we have studied in our lower grades. For example, sugar solution and salt solution. So they are the true solutions in which the solute completely dissolves into the solvent. So we are unable to see it. Like sugar solution, you cannot see it by your naked eye, you cannot see the particles of sugar. But if we use the microscope, then we can definitely watch them. Now what are alloys? See, alloy is basically made up of two or more elements, or you can say two or more metals. And the alloy has properties different from metals it is made of. So it has different properties from the metals that it is made of, like brass, bronze, steel. So they are made up of different metals, okay? But they are pure because they have a uniform composition. They are a uniform mixture. True solution is also uniform, right? Along with that, alloy is also uniform. So both of them are pure, as you're able to see in the image, right? And you can even download the PDF from the description box. It will be provided to you. Now moving on to the heterogeneous mixtures. Now I think we have discussed this. This we have discussed that the components are not uniformly distributed. Now what are the types of heterogeneous mixtures? First type is your suspension and the second type is colloid, which is very important. Colloid is super duper important. The properties are very important. The structure is important. Let's try to understand it. Now first let's talk about suspension. What is suspension? It is a heterogeneous mixture in which the solute particles do not dissolve but get suspended throughout the bulk of the solvent left floating around freely in the medium. So what happens in the case of suspension? The solute particles, let's say I'm putting sand into water. I have put some sand into water. So after some time you will see that sand settles down. Although it doesn't dissolve, but it remains suspended throughout the bulk of the solvent. So this is the true solution, and true solution becomes transparent. You are able to see through it. This is your suspension in which it's not dissolved, but it remains suspended. It floats. It can either float if its density is lesser than water, or it can sink if its density is more than water. Now properties of suspension are very important. It is a heterogeneous mixture and particles can be seen through the naked eye. We can see the particles. We can see the sand particles. The solute particles settle down when it is left undisturbed, that is, suspension is unstable. So it is not stable because the solute particles are settling down, right? They can be separated from the mixture by the process of filtration. Definitely, if you take a filter paper, the sand will remain on the filter paper, water will pour out. And particles scatter a beam of light passing through it and make its path visible. Suppose if you pass a beam of light, then they will scatter it all over, and you will be able to see the light. This is known as Tyndall effect, okay? And last, when the particles settle down, the suspension breaks and it does not scatter light anymore. So whenever they are like in the form of this, they are scattering all over, and that time Tyndall effect takes place. But once they settle down, then they do not. Okay, now moving on to Tyndall effect. What is this? It is the phenomenon in which the particles in a colloid scatter the beams of light that are directed at them. Colloid we will be studying in a minute. In a minute we will be studying, but just understand this. Suppose if I have this colloid. Okay, let's say this is my colloid. If I scatter a beam of light, then they will be directed in all of the directions and you will be able to see the light. The path of the light will be visible to you. This effect is exhibited by all colloidal solutions and some very fine suspensions. So Tyndall effect is this. Easy. Solute particles are scattering light and making its path visible. See, you're able to see the figure that light's path is visible over here. See the light's path. Okay, now moving on to colloids. What is this colloid all about? So the particles of a colloid are uniformly spread throughout the solution. Okay, it is uniformly spread throughout the solution due to the relatively smaller size of particles as compared to that of a suspension. The mixture appears to be homogeneous. See, the mixture appears to be homogeneous, but it is heterogeneous because the particle size is very small. Particles बहुत छोटे होते हैं, we cannot see them. Like milk के particles आप नहीं देख सकते, blood के particles नहीं देख सकते because of their size. That is very small. But अगर microscope से देखोगे, then you will be able to see a lot of fine particles. This is about a colloid, right? Now moving on to the properties of colloid. So what are the properties of colloid? Tell me guys. What do you think? Now first thing, the particles of a colloid are uniformly spread throughout the solution. They are spread uniformly. Unlike suspension in which particles were not spread uniformly, right? Now due to the relatively smaller size of particles as compared to that of a solution, suspension, the mixture appears to be homogeneous. Okay, it appears because you cannot see the particles. But actually a colloidal solution is a heterogeneous mixture. Remember, it is hetero. Because of the small size of colloidal particles, we cannot see them with naked eye. These particles can easily scatter a beam of visible light. That I have already told you. Now let's have a note. The solute particles don't settle down when it is left undisturbed. That is, colloids are stable. So see, generally if this wouldn't be the MCQ based pattern, then you would get some question related to distinguish between colloid, suspension, true solution. But now it's not there, so you're lucky, right? Okay. So colloids are stable. By this we are able to understand. Now moving on to the components of colloid. The components of colloid can be the dispersed phase or the dispersion, or you can dispersing or dispersion medium. Now what is the dispersed phase? The solute-like component or the dispersed particles in a colloid form the dispersed phase, which are like your solute, the solute-like particles. Okay, they are the dispersed phase. Clear? And what is the dispersion medium? It is the component in which the dispersed phase is suspended. Is known as the dispersing medium. So it acts like the solvent. And the solvent of colloid is dispersion medium. Solute of colloid is dispersed phase. Now types of colloids with examples. This table is given in an NCERT from MCQ perspective. This is it's very important. Now you have the dispersing medium, dispersed substance, and colloid type. So you can just have a look like fog, aerosol, sprays. These are the examples. These are the colloids. Here the dispersing medium is gas, dispersed substance is liquid. So this table you can learn right now. It's just direct what is the solute, what is the solvent in this case. Clear? Now moving on to solutions. Solution is a homogeneous mixture, as we know. Solution or true solution. Mixture don't have a fixed composition. It can have variable composition. Okay, mixture can have a variable composition. So the combination of a solution can be varied, right? The relative proportion of solute and solvent, I think it should be solvent, can be varied. So they can vary the proportion of solute and solvent, how much it is. Okay. Now moving on to components of a solution, solute and solvent. So you have two components of the solution, solute and solvent. That you know, solute, which is the solid-like structure which is dissolved into the solvent, which dissolves the solute, and these two form the solution. Correct? Now moving on to concentration of solution. Now wait a second. So what do I mean by concentration of a solution? Let's say you have taken dilute copper sulfate solution. This is a solution, and you are adding more and more copper sulfate, which is blue in color. So you're adding more and more copper sulfate into it. Then at one point it will become concentrated. What is the meaning of dilute? Dilute means when there is more of water, less of copper sulfate, and in general terms, when there is more of solvent, less of the solute. And concentrated means when you're adding more and more solute, then the amount of solute increases and it exceeds the amount of your solvent, right? It becomes more. Okay, so this is about your concentrated solution. And at one stage, एक stage पर क्या होगा? It will become saturated. Saturated means एक stage आएगा जब आप solute add करना चाहोगे but वो dissolve नहीं होगा. Why? Because all the space has been occupied. Now no more solute can be dissolved into that solution, into that solvent. This is known as saturation, and the solution is saturated solution. But here we have to focus upon the concentration of the solution.
Okay, so let's understand what is concentration exactly. So mathematically, concentration is equals to amount of solute upon amount of solvent, or we can say amount of solute upon amount of solution. So this is your concentration of any solution that we have to understand over here. Now moving on to saturated solution. When no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. It means I can say that all the space has been filled in the solution, right? Has been filled, and that's why you cannot add no more solute, as it is what you can say concentrated to saturated. Okay, now it is saturated, that's why now it is completely solid. Now moving on to solubility. What is solubility? It is the amount of the solute present in the saturated solution at this temperature. So solubility is the amount of solute which is present in that saturated solution. Suppose I have this beaker in which I have a saturated solution. Okay, I'm having a saturated solution over here. So the amount, the mass of it, the solutes, that will be our solubility. Now moving on to expression of concentration, it can either be in the form of mass by mass percentage or mass by volume percentage. Okay, so these two things are there with us.
Percentage. Now first we will be discussing mass by mass percentage of a solution. So we are trying to find out the percentage through mass of the solution. So what is the percentage formula? Mass of the solute upon mass of the solvent into 100. Please, many students write solution actually. Many students write solvent, it is solution. By mistake I said solvent, sorry. It is mass of the solute, it will be given to you in the question. Mass of solution will be given to you, you have to multiply by 100 so that you can get your, yeah. Next, the question, sample question that we will be solving. Just a second, let me change my orientation. Stage of concentrated solution. Now, another form is mass by volume percentage of a solution, and the formula is mass of solute into 100 upon, say sorry, mass of solute upon volume of solution into 100. Now this is your homework question that you will be solving and letting me know in the comment section. A solution contains 40 grams of sulfuric acid and 320 ml of water. Calculate the concentration in terms of mass by volume, percentage of the solution. And density is given to you this. Okay, let me know in the comment section. Now we are moving on to separation. See, you can say the true solution, the pure substances cannot be separated, but the mixtures can definitely be separated. How can we separate them? There are various physical methods by which we can separate them. Here is the list of your methods by which we can separate. So evaporation, centrifugation, separation by separating, funnel, sublimation, chromatography, distillation, fractional distillation, crystallization. So let's study all of them. Now first thing, sublimation is very simple. What happens in sublimation? It's quite simple, not very tough. It's nothing but, see, there are some of the solids which directly get converted into gas. Okay, they are the sublime substances. Like for example, you can take ammonium chloride, that is your NH4Cl. NH4Cl is your ammonium chloride. If you take that and you start heating it in a burner, you will see that it will disappear. Where? In this process, what happens? So what happens? The solid that we have, it directly gets converted into the gas, skipping the liquid stage. So liquid stage is not going to be there. Solid will directly convert into gas. Okay, everyone? Sublimation, right? Now, what are the examples of solids which are sublime, like ammonium chloride, camphor, which is known as kapoor in Hindi, right? Naphthalene and anthracene. Naphthalene balls jo aap dalte ho apne clothes mein. So these all are sublime substances, right? Now, moving on to evaporation, that is the next process. So one activity has been set up over here that we have to perform, in which water is taken in a beaker, which is heated, and we have a dye over here which is left behind, because when the dye was mixed with water, then what happened, that the water got evaporated when we heated it. The liquid converted into gas over here. Water was a liquid which converted into gas, it evaporated, right? Now what is crystallization? Now the crystallization method is very important, and it is used to purify the solids. Now in this process, the pure solid that is obtained is in the form of the crystals, is in the form of the crystal from a solution. You get that solid, right? Now, why is crystallization better than evaporation? There are two reasons. Okay, so in crystallization, what happens when you, like in evaporation, we are heating and we are getting the solid behind when the water is left behind, as in this activity it is shown. Suppose if you have salt solution, then if you heat it, water will evaporate, salt will be left behind. So in this manner, you can separate. And here also, as we talked about, you can separate any substance which, any two substances in which one of it is sublime. Here you have to separate a liquid with a solid. If you want to separate, then it will be separated. In crystallization also we have the same thing, but the difference is that it is in this crystals are obtained instead of the solid. It is purified, and the reason is that it's better than evaporation, because some solids decompose, or some like sugar may get charred on heating to dryness. Some solids may get decomposed if you heat them, and some may get charred, some may become black on heating, right, to dryness. Some impurities may dissolve in the solution even after filtration or evaporation. These contaminate the solid, so you wouldn't get the purest form of that solid, since that is going to be contaminated, that is going to be impure. That is why crystallization is better, right? Now what are the application of crystallization? First is the purification of salt that we get from seawater. Okay, that is formed, we get the crystals of salt. Many of you might be thinking we use evaporation. No, we use crystallization. For getting the purest form of salt that we eat. Okay, and separation of crystals of alum, that you call fitkari in Hindi, from impure samples. So you can easily separate these crystals. Clear? Okay, now chromatography. Same. Yeah. So chromatography, here chroma means color, right? So the technique is used for separation of those solutes that dissolve in the same solvent with different extent. So the solutes separate out in layers depending upon their solubilities. Okay, so this is about chromatography. So they're going to be separated in layers that we will be getting. Okay. Now by this we can, when activity is given to you in your NCERT, so that activity is that you have to place a dot on the paper. Actually, this is the sample ink. This is the ink that you have to place, and here is your water. What happens? Mobile phase means water is not moving, right? And paper, you can take any stationery, okay, which is not moving. So what will happen? Slowly the water is going to rise. Okay, this is a mixture of various colors. So as the water will rise, the substance or the matter which is more soluble in water will rise with water first. Then the next one, then the next one. So we will get layers of it. We will get layers of it, of the different particles based on their solubility in water. So this is nothing but your chromatography. Easy. Now applications like to separate colors in a dye. When you have a dye and you have to separate the different colors from it, then which technique would you use? Chromatography. Whichever color is most soluble will rise first, then the second one, and here you will be getting the layers. Then you can easily separate it out. Okay. To separate drugs from the blood, in that also your chromatography is used. Okay, ignore my handwriting, right? Now moving on to centrifugation. What is centrifugation? You've heard this term in your lower grades. And this is the method which is used to separate those solids which pass through the filter paper in the solution form. See, basically what we are doing it, we are separating those solids which pass through the filter paper in the solution form. So it is a kind of liquid. And what is the process? See, what do we do? Suppose we have, see, we have a centrifugal, or if you have that stick by which you churn something, you churn that colloid. Basically it's for the separation of colloids. So when you churn it, then what happens? The lighter particles come at the top and denser particles are forced to settle at the bottom. So lighter particles are at the top, denser at the bottom. That's in this manner you can easily separate that out. So using centrifugation you can definitely separate that out. Now what are the applications used in diagnostic laboratories for blood and urine tests, using dairies and home to separate butter from cream? Butter from cream is separated by the churner also if you have, okay? But also what happens, the you can say butter, it starts coming on the top, and then we can easily, because it's lighter, right? Now used in washing machines to squeeze out water from wet clothes. And a washing machine also is based on the application of centrifugation. Are you all able to understand? I hope that you are able to understand it. Now moving on to the distillation. Yeah, so what is distillation? It is used for the separation, what is happening? Yeah, it is used for the separation of components of a mixture containing two miscible liquids. Miscible means two liquids which mix in each other, which are mixing in each other. They are known as miscible liquids that boil without decomposition and have sufficient difference in their boiling point. So boiling point is the minimum temperature at which the substance starts boiling, right? So first of all, three conditions we have. First of all, they should be mixed in each other. Okay. Second, that boils without decomposition. Decompose नहीं होने चाहिए वो liquids, black नहीं होने चाहिए, जलने नहीं चाहिए. That should be the second condition. Have sufficient difference in their boiling points. Boiling points में sufficient difference होना चाहिए, right? Now the separation of mixture of two miscible liquid. This is the diagram given in your NCERT. We have a distillation flask. Then what happens? See, we have a distillation flask over here. When we heat it, the liquid starts evaporating. The substance which has the lower boiling point will evaporate first. The other substance will remain over here. Then here you can, from here the gas will be evolved. It will be evolved in the gaseous form, this substance which is having the lower boiling point, because it will be boiled, and afterwards when this boiling point reaches at a stage, you can close it and the second liquid can be poured out from here. This will convert into gas, and here you will be getting your liquid which is having the higher boiling point, which did not boil during this time. Okay, understood everyone? Which did not boil during this time. So here it has been converted into gas, and here you can get the liquid, the second liquid. I hope that is clear. Now moving on to fractional distillation. Now this is the process which is used to separate a mixture of two or more miscible liquids for which the difference in boiling points is less than 25K. See, this is distillation is used when the difference between the boiling points of both the liquids, that is more than 25 Kelvin. But if it is less than 25 Kelvin, we use fractional distillation. What do we do over here is that, wait a second, yeah. Now let's try to understand about fractional distillation. What happens over here, that we place a fractionating column above the flask and then we start heating it. So as I told you that this fractionating column has beads in it, and as these are the two liquids, and when the first liquid which has the lesser boiling point will pass through it, it will go away, and when the second liquid will try to pass through it, these beads will condense that and then it will again settle down. Right, so right now it is passing by the first liquid, and the second liquid, when it will try to pass, because of its solubility their difference is less than 25K, so second liquid will also start heating with it, so it will finally pass through the beads and again come down because of condensation. These beads will condense it, and that's where this fractionating column is going to help us. Afterwards, when the first liquid evaporates, then we can get the second liquid again at when it reaches its boiling point. Whenever it reaches, then again it will also start evaporating, and then we can easily get it in the beaker. So this is all about your fractional distillation. Okay everyone, so like we saw over here also in distillation, in which we were talking about miscible liquids, here we have the beaker. Okay, so you can able to see these beads condense it, and then again it will go down, and soon after we can collect it in this tube. Easy, it's not that difficult, I would say it's pretty easy. Now in example, different fractions from petroleum products, you get that they are separated through fractional distillation. Centrifugation we have done now. Separation by separating funnel. Now this is to separate two immiscible liquids which do not get mixed with each other, and the principle is that immiscible liquids separate out in layers depending on their densities. Wait a second. The liquid which is more dense will be at the bottom, and which is less denser will be at the top. In this manner they will separate out. So same here, you can take the example of kerosene, oil and water. They are immiscible, so oil is denser than water, so it will be at the top as you're able to see, and water at the bottom. Then you can separate out water, and as soon as oil is about to reach here, you can place the stopcock, which will prevent oil from entering into your new beaker where you are putting the water. Easy. Now some of the applications of the method using same principle to separate out oil and water. In the extraction of iron from its ore, the lighter slag is removed from the top by this method to leave the molten iron at the bottom of the furnace. So these are the two things that we use over here, right everyone, so that you can easily understand, right? It's not that tough. So we have finished with today's session, and I hope this session was very helpful. NCERT activities, if you want to get the explanation in depth, do let me know in the comment section. I will make a session on that. Actually, it was purely MCQ based your paper is going to be, so I did not focus on that much. But if you want, I can definitely teach you, right? Now, homework question that you have to let me know in the comments is that name a technique which can be used to separate drugs from blood. What do you think? Which is that technique? I will be waiting for your answer, and thanks for attending today's session. Do like, do share, do subscribe to the channel. And as I always say, stay happy, stay hydrated, stay fit, guys. Bye bye. Take care. Shibaka.